Hello everyone. Today we are going to solve Zone Informatics Olympiad 2019 question papers question 1. Right. So I have tried 2021's question 1, but I could not solve it. That is, my answer was wrong. So I'm recording this video because I want to check my skills and probably recheck whatever I'm doing wrong in the future. Right. I took this question paper from CodeChef's website. Here's the question paper link, and we're going to check the answer later, right? Yeah, let's start. So here's the question number 1. A sequence of positive integers a1, a2, a3, an is called special sequence if a1 divides a2 and a2 divides a3 and so on until an minus 1, right? Let me zoom in. Yeah, that's it. All the and if all the elements are distinct. For example, 2, 4, 8, 32 is a special sequence, but 4 to 8 is not, because 4 does not divide 2. Similarly, 2, 4, 4, 8 is also not special sequence. Special because the elements are not distinct. That is, 4 is repeated twice, right? We need to find the number of special sequences such that all the elements of this sequence are from the set 1 to k. Suppose k equals to 3, the special sequences possible are 1, 2, 3, 1, 2, 1, 3. So the answer would be 5, right? And we are given three cases, right? For k equals to 15, 19, and 22, right? So the so we have to take subsets from 1 to k such that they form special sequences. Now, what is a special sequence? A special sequence is one in which the first term of the sequence divides the second term, and the second term divides the third term the fourth term, and so on until the last term is divided by the last but 1th term, right? That is the basic gist of this problem, and it depends on that. Now we are going to solve this. Let me switch to whiteboard. Just a minute, guys. Yeah, that's it. Yeah. So here we are, right? So we given a set such that it goes from 1 to till k, right? Yeah, that's the set. And from this set we have to make subsets such that they form special sequences, right? And we are given 3 cases, k equals to 15, 19, and 22. But before going ahead to the question, I want to first check if there is going to be any formula that we are going to get, right? We can do this by substituting k numbers by ourselves, by taking different k values like 1, 2, 3, 4 till 4 or 5, and if we get a formula, we can use that formula to solve all these cases, right? So we're going to do that. Let me make this full screen. Yeah, right. So first we're going to take k equals to 1. 1 second. Yeah, k equals to 1. So the set will be 1. That's it. So the number of subsets, right? The number of subsets, I mean not the number of subsets, but the subsets will be a null set and 1, right? These are the subsets, but we cannot include null set because there is no number to be divided, and 1 is a special sequence, because in the problem we are given that for in the example k equals to 3, even 1, 2, and 3, that is singleton sets, are also special sequences. So we can take this, and here our answer is 1, right? And for k equals to 2, we'll have this set 1, 2. From this set we have to create subsets. So the subsets will be null set 1, 2, and 1 2. From now on I'm not going to include null set because we know that it is not going to be a special sequence, right? And 1 is a special sequence, 2 is a special sequence, and 1 2 is also special sequence because 1 divides 2, right? So here we have 3, right? And now we'll go for k equals to 3. I'm directly going to I'm sorry, not that. Yeah, here we get 1 2 3. Now we get 1 2 3, and there are going to be other subsets, right? Yeah, I'm going to write it here. You will understand why. So we'll have 1 2 1 3 2 3, and that's it. 1 2 3 4 5 6 7. There's going to be one more. 1 2 1 3 2 3. Yeah, 1 2 and 3. Yeah, we have not included null set, so we're going to get 7 terms, right? Now let me just, this is a subset, this is a subset, this is a subset, this is also a subset. I mean special sequence, sorry, my bad. Special sequence, not a special sequence, right? This is not a special sequence, and this is also not a special sequence, as given in the example. We can clarify that from that. So we get 5 of this. Let me just clear this off. We get 5, and from here this is not a special, or not this one, right? From this, for future subsets, we can conclude that if something is not a divisible, not a divisor of another number, we can just exclude that subset, right? We'll use this in next case, right? K equals to 3. Let me just move this. Yeah, k equals to 4, sorry. We'll get 1 2 3 and 4. The subsets will be, of course, singleton sets. From now on I'm going to write singleton sets, right? This one, and we're going to write subsets which contain 2 elements: 1 2 1 3 1 4, right? These are all special sequences, right? We will also have subsets which include 3 terms. That will be 1 2 3. Now we already know that we won't get this won't be a special sequence, because we already got that in k equals to 3 term, right? So we should not include this in our answer. So we're directly going to 1 to 4. Yeah, that's one thing. Next is you won't get any other thing. Yeah, actually I forgot about some other double sets, right? Let me just write that down. So we'll also have 2 and 2 4, 2 and 4, 2 4. Yeah, is there anything else? Let me check. 1 2 1 3 2 3, not possible. 2 4 is possible. Yeah. And next is sets which contain 3 terms. We already concluded 1 to 3 is not 1, so we'll take 1 to 4. 1 to 4. Next we can take 1 3 4, but 3 is not divisible by 4 is not divisible by 3, so that is not an option. Next is 1 2 3 4, which is also not possible, so we're going to have yeah, that's it. We'll have 1 2 3 4 5, 5, and then singleton sets will be 4. Let me write that down. 4. So 5 plus 4 is 9. We got 9 for k equals to 4. Similarly, we'll do it for k equals to 5 as well, just to conclude if it is a pattern, because we can already see that 1 3 5 9, we are getting a pattern, but we have not included 7. If 7 was there would be a definite pattern, right? But just to be sure, we are going to check for k equals to 5 also, right? For k equals to 5, we'll have 1, 2, 3, 4 and 5. Here we'll have singleton, which are 5, singleton are 5, and we'll obviously have 1, 2, 1, 3, 1, 4 and 1, 5, right? Next, we can take 2, 4, and we cannot take 2, 5, so the 2's are over. 3, 4 no, 3, 5 no, 4, 5 no. So these are the only double sets, right? Next we'll go for triple sets. 1, 2, 3 is not possible. 1, 2, 4 is possible. 1, 2, 5 is not possible. Yeah. Then we'll check. 1, 3, 4, 1, 3, 5 not possible. 1, 4, 5 not possible. Yeah. So we'll take 2, 4, 5. 5 is not possible. So this is the only thing that is possible, right? Let me check if there are going to be any other subsets which are special. 3, 5, 6 is possible, but 6 is not there. Yeah, that's it. So the total number of special are 1, 2, 3, 4, 5, 6 and 7 plus 5, which is 12, right? Let me zoom out a bit. Yeah. Yeah. So we got this sequence, right? For k equals to 1, k values will be put here, and values that we got will be put here. Now for k equals to 1 we got 1, for k equals to 2 we got 3, 3, 5, 4, 9 and 5, 12. Now if you check something, you can see that for k equals to 2, the subsets 1, 2 and 1, 2 contains the subset 1, which is included in k equals to 1. Yeah, k equals to 1, right? So that is already included in this, and we are getting additional things. So we got 3. Similarly, here 1, 2 and 1, 2 is included in k equals to 2. This is also included in k equals to 3, 4, 5. So you can check that we are getting the same terms in several of them, right? So for these sets are included in k equals to 2, k equals to 3 and k equals to 4 and 5 as well. So no matter what, if you take k equals to n plus 1, the k equals to n subsets will already be included in k equals to n plus 1 subsets, and there will be special subsets, of course, right? So all we have to do is check the subsets, the additional subsets that we are going to add, right? Let me check if there's going to be any formula. Yeah, right. I got a potential formula which might be true, because for let me zoom in. Yeah, for odd numbers, odd numbers there is a potential formula that number of special sequences equals to twice the number 2n minus let me check 1 second, minus 3 this is wrong. Yeah, this is wrong. Let me clear this. Let me check if I get a formula. 3 5 2 right, 9 plus 3, this is 2, this is also, this is 4, this is 3. That's not any pattern. 2n plus 2, 2n minus 1, 2n minus 2, 2n plus 1, 2n plus 1. Right, I'm not getting any of these what do you call formula, so we'll have to check, we'll check for a few more, for 6 and 7 also we'll check, right? Yeah, let me let's check for 6 and 7. For 6, okay, equals to 6. K equals to 6. The set will be 1, 2, 3, 4, 5, 6. Now, from our conclusions, we have already got that K equals to 6 will already contain the number of subsets which form a special sets from K equals to 5. So we'll already have 12 plus 1 because singleton set of 6 is added. So we'll have 13 sets, right? 13 sets already included from K equals to 5. So we're going to write K, 1 second, let me, yeah. So we'll have 6 singleton, and we'll have 1, 2, 3, 5 of these pattern recurring, 1, 1, I mean 1, 2, 1, 3, and so on till 1, 6. These will be 5, right? And afterwards we'll check for 2. There is one thing which is 2, 4, 2, 6 also, 2, 6 also, right? Next thing is 3. We have 3, 6 now. 3, 6, that's it. And for 4, we don't have anything, nor for 5, nor for 6. So we can see a pattern occurring that once if the length of this set is 6, the terms which are more than half of the length of these are not getting any double sets, right? We are not getting any double sets. That is what we are seeing. So we won't have any anything called 4, 5 or something like that, right? Yeah, that's the pattern. Now we are also going to check for triple sets. Triple sets is a bit interesting. Let me see. So we'll have 1, 2, and 3. Sorry, that's wrong. We'll have 1, 2, and 4. 1, 2 and 6. That's it. We'll also have 1, 3 and 6, and we won't have anything which comes with 1, 4 or 1, 5 or 1, 6, right? So we'll go for 2, 4, and is 6 divisible by 4? No, we won't have that. 2, 4, 6, no. Yeah, no, we won't have that. 3, 4, no, 3, 5, 6, yes. Yeah, this everything we want, right? We have 6 singleton plus 6 plus 5 of these. 6 plus 5 is 11. 11 plus 3 of these, 14. 14 plus 3 is 17, right? This is 17. Now we have seen pattern, right? For any number k equals to n, we'll have n singleton sets, right? N singleton sets, and n minus 1 sets which have the first first element as 1 and the second element as n as a subset includes n, right? 1, 2, 3 or something, right? We'll have n minus 1 of these. And for these 2, 4 or 2, 6, if we have for, yeah, let me think. Oh yeah, I got a pattern, right? For these sets which have 2 in the first place and some x number which is from k subset. This will include as many subsets as there are as there are which are divisible by 2, right? So for in k equals to 6, we have 3 elements which are divisible by 2, but we have to exclude 2 because they have to be distinct. So we'll have number of elements divisible by 2, number of elements divisible by 2 minus 1, right? Yeah. And for 3, that is similar to that. It should have number of elements divisible by 3 minus 1 because they should be distinct again, right? That would be same for every double set, provided that the condition is that the first element should have the number of divisible elements minus 1, right? That is the number of singleton sets we are going to get. And for triple sets, let me think of something. We'll have 1, 2 and 4, 1, 2, 6. Right, I'm not getting anything for triple sets, so we'll continue with the conclusions we have for now, right? K equals to 7, we'll write this and we'll use the conditions, right? We'll have 1, 2, 3, 4, 5, 6 and 7. So we'll have 7 singleton sets, and we'll have the sets of this format where x is a term, x is a number, of set k, so we'll have n minus 1 of these, so that will be 6. I'll write here n minus 1. Do not confuse this with exponent, right? N minus 1 sets. Similarly, we'll have 2 and here x. 2 and here x, right? How many numbers are divisible by 2, right? For that, we'll divide the k. We'll divide k value by 2. So we'll get, and this is a greatest integer function. So we'll get 7 by 2 of greatest integer function, which is 3, right? We'll have 3, but we have to exclude 1 because one set will be 2 comma 2, and we cannot have that, right? So we'll have only 2 of those. You can use the same formula or similar formula for different numbers which are included in the first case. So we'll have 2 sets, and for 3 of x we are going to have, let me check, 1 set, and for 4 of x, we are going to have 0 sets. Since we have 0 sets, we don't have to calculate for the 5 comma x or 6 comma x or 7 comma x, because of course they're going to have 0 sets, right? Now for triple sets. Obviously we're going to include the sets in the above things. So that will be 1 to 4, 1 to 6, right? This is going to be 1 set, and we'll have 1, 3, 6 as well. 1, 4, 1, 5. Yeah. Oh yeah. I can see a pattern here, right? So can you see that if the first element of the triple set is 1, the number of subsets which are also special sets equals to 3. This is the same as the addition of these two, right? This is also 3. So if the first term is 1, the second and third term can be will be the subsets of other double sets, right? Right? We have 3. That is for only the first term is 1 in a triple set. Now we have to check for number starting with 2. Number starting with 2 will be, if you assume 4, we have to get 8. That's not possible, and there are no other cases for that, right? So we'll check for 3. 6, we'll have to get 12, so that's not possible, right? And for 4 also it's not possible. So potentially we have calculated a formula, right? We'll have from our conclusions, let me write it in blue, we'll have n singleton, right? N singleton and n minus 1 plus n minus 1 1 of x type of sets, right? Let me know this, right? And greatest integer, one second, yeah, greatest integer of n by 2, 2 comma x sets. Similarly we'll have greatest integer of m by 3 and till n by n sets, right? Even if the middle n by 4th is 0, n by n will automatically be 0. And for what do you call, triple sets, as far as I know, for triple sets, we can conclude we'll have the same as the number of double sets, right? We'll have the same as the number of double sets. 1 of x comma y type of sets will have equals to number of double sets, right? We have not gotten 2 of x comma y because we still haven't gotten till k equals to 8. If we got till k equals to 8, we would have gotten this, right? For now we are going to go for k equals to 8 as well, just to know what happens if we get 2 comma x comma y also, right? Correct. Right. Yeah. So we'll have k equals to 8, right? So we'll have 8 singleton and 8 singleton, n minus 1 comma x type of sets, so that is 7, and 2 by x is 2 comma x is a greatest integer of 8 by 2, which is 4. 3 of x is 3 of x is 8 by 3, greatest integer, which is 2. 4 of x is 1, and 5 of x will be of course 0, so we won't calculate that. Next we'll calculate 1 of 1 comma x comma y type. We concluded that we will get some of these things, so which is 7, right? 7. And for 2 comma x comma y, let's manually do something, right? We'll have 2, let me write this set, 1 2 3 4 5 6 7 8, right? Yeah, we can have 2 4 8, and that's it. That's the only thing we got, right? This will be, as far as I know, if n exceeds, n is greater than 2 power n is greater than 2 power 3 for singleton sets, right? Greater than or equal to, we'll have 1. Let me see. This is a bit complex. Right, yeah. I found a what do you call? I can't remember the name, but let me tell you something. If you have 2 comma 4 comma 8 as a special set, right? After this 2, you'll have 4, right? Let me see. One second. I also have made a mistake here. Yeah. So we'll have only 3 of these, my bad, and 1 of these. That's it. Yeah, 3 of these and 1 of these. That's my bad. So we have to calculate this again. Yeah. we'll have, this is also one, so we'll have 5 of these, right? And for this I found a trick, 2 4 8. Since the next term is divisible by 4, we have to go for 4 of x. How many other terms are there in this? Those are the number of terms for 2 comma 4 comma x, right? 2 comma 4 comma x. So that will be 1. Let's say we have 3 comma 6 comma x, right? So we have to go for 6 comma x, and if it has 3, let's say for example it has 3, so this will have 3, right? Like that. You can get the gist of it, I guess. I am not able to explain it in perfect way, but that's the main trick, I guess. Yeah, so we have 1, right? And for 3 comma x comma y, we'll have 0, right? Yeah, we'll have 0. And are there any 4 sets? 1 2 4 8. Yep, there is a 4th set, I mean 4 term set, which is 1 2 4 and 8, right? How do you get a 4 set? Let me see. Yeah, I'm not getting a pattern, but I think if for sets 1 comma 2 comma x comma y, the general form is that if n is greater than 2 power 1 2 3 2 power 3, you are going to get 1 set, right? And similarly for 1 comma 3 comma x comma y, if it is greater than 3 power 3, you will get a 4 set. Yeah, that's a basic gist, right? So we have 1 here also, and we won't have any 5 sets as far as I'm aware. Let me check. 5 sets. No, that's it. Yeah. So now the total thing is 7 plus 3 plus 10. 12, 14 plus 5, 19, right? We'll write these values there, wherever we have kept the other values. 17 and 19. So we only got 2 sets extra here. Why is that? Yeah, that's it. So for 6 we got 17, and for 7 we got 19. But the basic thing we got is that we understood how many sets we are going to get, right? How many singleton sets, how many double sets, and all that, right? From this we can now go ahead into the problem. Let me bring that question up. First question is k equals to 15, right? Let's go back. My PC is slow. I have a nice cat. Yeah, 40 minutes. Wow. Real exam I would have finished, I should finish in 5 minutes by now, right? Each question is for 45 minutes only, right? Right. But this is for practice, so I don't really care, right? Yep. equals to 15. I'm going to write the whole set because it's going to help me, I guess. 14 and 15, right? The number of singleton is 15, obviously, and the number of sets which are in the form of 1 comma x is n minus 1, which is 14. Number of 2 of x is minus 1, right, 15 by 2 minus 1, which is 15 by 2 is 7, greatest integer, minus 1 is 6. 3 comma x is as that 15 by 3 minus 1, which is 4. Similarly, we have to do this until let me see, until 7, yeah, we have to do that until 7. I'm going to do directly, right? Why did I do it till 7? Because as soon as you go beyond the last digit by half, plus one's element, let's say we're going to 8. Now what is the greatest integer function of 15 by 8? 15 by 8, this will be 0. If 15 by 8 is 0, it will be 0 for all these terms, right? That's why I didn't do it for 8, 9 till 15, right? Now we'll check for 1 comma 2 comma y, right? We'll check this 1 comma 2 comma y. So to check that, we'll have to let's go down and see what I have done. 1 comma x comma y, we got 5 because this, 1 comma x comma y, x comma y equals to let's see, 2 comma x, 2 comma x, 3 comma x, right? We have to add this is 10, 12, 13, 14, 15. We'll get 15 of this, 2 comma x comma y. Now we have to select such that from this, the what do you call, then the first element must be divisible by 2, and the next element should first element that's it, yeah, so it should be divisible by 2. So we can choose 4, let me take, we can choose 4, we can choose 6, we can probably choose 8, but it's not there, so yeah, that's it. We're going to have 3 of these equals to 3. Similarly for 3x comma y, it is same as that. We can choose 6, right? That is the only thing. We will get one set, right? One set. For 4, we can't choose anything, so that's it. Yeah, now we'll have 4 sets, right? 4 sets as far as I know. Yeah, 4 sets. I think I found something. Yeah. So 4th set will be 1 comma x comma y comma z, right? This will be this will be same as sum of these two. Sum of these two will have 4 of this, right? Because as if you observe earlier that for 1 comma x comma y we added all these terms, right? Because they just fit well and they are not they are distinct. That is the condition, right? Similarly, if you choose these two, we'll get 4 of these, right? Yeah, that's the what do you call it? Trick, I guess, or conclusion. I'm going real slow here, but there is practice, so I don't really care. That's it. And for 2 comma x comma y comma z will have 0 because we don't have 4 comma x comma y. If we had 4 comma x comma y, it would be possible that we will have at least one of these, but we don't, right? Yeah, and for 5 element sets A, B, C and D will have 0 because we don't have any 2 comma x comma y or 3 comma x comma y comma z, so we'll have 0. So the number of sets for this, let me count. For k equals to 15, this will be 14 plus 6 plus 4, that is this is 20, 24, 24, 26, 26 plus 3, 29, 29 plus 1, 30, 33, 30, 48, 48 plus 4, which is 52. We got 52 for this, right? I'm going to check the answer. If it's correct, it's okay. If it's not correct, I'm going to revise my what do you call conclusion, right? Just a minute, guys. My PC is slow, don't worry. 2019, right? Yeah, 2019. And answer key, what did we get? 52. 52. Special sequence is 69. So we must have probably missed something. 69, 52. How many is that? 17. We missed 17 of those. The number of 2 comma x will be 2 comma 4, 2 comma 6, 8, 4, 6, 8, 10, 12, 14, that is 6, yeah, that's correct. And for 3, it's 3, 6, 3 comma 6, 9, 12, and 15, that's 4, yeah, that's also correct. And for 4, it's 4 comma 8 and 4 comma 12, that's correct. 5 comma 1, sorry, 5 comma 10 and 5 comma, yeah, here we did a great mistake. So for 5 we'll have 2 sets, right? For 5 we'll have 2 sets, so plus 1 we got 53, we still have more to do. For 5 we have 2 sets, for 6 we have 1, 7 we have 1. Yeah, this significantly changes the answer because now we have this 2, we are going to add plus 1 for this. This is 16, so plus 1 again, 16, right? So we're going to have 16 on that, and 2 comma 2 comma 4, 2 comma 6, 3, 8 is 0, yeah, that's correct. 3 comma x comma y is also correct. 1 comma x comma y comma 0. I'm not sure why I'm not getting this, but I got 54 for now. Let's see. 54. Okay, equals to 15. Let's just check the question if it's I mean, if I've taken the value k equals to 15, or is it that is k equals to 15. Let's check 2, 4, 8, 32 is a special sequence, and it should not contain. Okay. Let me check the answer. Solution, I mean. Solution 29. Okay. Because as far as I know, my question, my way of doing the question was right. This is a different question. What on this? Let me check also. That should always be the multiple, right? Yep. I am correct, but I'm not sure where I'm going wrong. It should be increasing. So that will be 6, 12. 18 is not I think let's say counting mistake. Let me check. 15 plus 14. 15 plus 14 is 29. Let me get a calculator. Plus 2 is 4, 4 plus 2 is 6, 6 plus this is 10, this is 16 and 4, 15 plus 4 is 10 plus 19 plus 1, 2, 3, 4, 5, 6, 69. Is that correct? Is that correct? Yes, sir. 69. Yep. Okay, so my way of doing it was correct, but I made a mistake here at 5 comma x, so I got 2 difference, so we'll take that as no. So now we'll do for second value, right? Yeah, this is probably this what do you call it? My recording is probably very lengthy, but it gives a beautiful insight into how humans think, right? How to solve also. So k equals to 19. K equals to 19. Can you do that? Spent an hour for this one. K equals to 19. Singleton equals to 19. 1 comma x is 18. I should probably know this. This is not nice. lagging like hell. Yeah, that's it. Yeah, and we'll have 2 of x as, let me see, we'll have 8 of this. 3 of x is, we'll have 5 of those. 4 of x, 4 of x is 3. 5 of x is 2. 6 of x is also 2, I guess. Yep. 7 of x is 1. 8 of x equals to 1. And 9 of x, it will be 0. No, it will be 1. Yeah. See, that's how we make mistake. We'll assume that it will be 0 or something else, but actually it's not. Right? Right. Now we'll have triple sets. This will be 1 comma x comma y, which will be the sum of all these things, right? Let me zoom out and see, calculate the sum. We have 3 ones, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 13 is 23, 23, 23, 2 of x comma y. What we have to do is subtract 8 from that, which is 15. 3 of x comma y, subtract 5 from that, 10. 4 of x comma y, sorry, equals to subtract 3 from that, which is 7. 5 of x comma y, subtract 2 from that, which is 5. 6 of x y, which is 3. 7 of x and y is 2. 8 of x and y is 1, and 9 of xy won't exist because that will be 0, right? Well, now we are going to use quadruple sets or 4 sets containing 4 elements. I should use x, y, z. That will be same as the sum of all these other things, right? So let's count 15, 25, 32, 37, 40, 43. We'll have 43 of this. 43, right? 2 of x, y and z, that will be 43 minus 15, which is 28, and 3 of, I'm going to write this double quotes, which means copy the above thing. That will be 28 minus 10, which is 18. 4 of x comma y comma z is 18 minus 7 is 11. 5 comma this is 11 minus 5 is 6, right? Yep. 11 minus 5 is 6, and 6 comma x comma y is 6 minus 3, 3. 7 comma this is 1, right? And again we won't have 8 comma x comma y comma z, because that will be 0, right? Now we'll use this 1 comma a comma b comma c comma d. We have 5 elements. These 5 elements will be the sum of these things, right? 28 plus 18 is 38, 46, 46, 52, 52 plus 11 is 63, 63 plus 4 is 67. Man, the value is getting bigger, right? Are we sure actually? I think there's a big problem here because the value is just increasing, right? Did you see here? That's correct only, I guess. Oh man. As I said, this is how we make mistakes. This is actually how we make mistakes, right? There's a big mistake here. Let me just clear all this. So the singleton sets and double ton sets are okay, but triple sets, these are so wrong. And the DC is so clear this out. So the wrong thing I have done is that I added everything. Instead I had to add only which are the multiples, right? Which were the multiples of the first numbers, right? Instead of that I added everything. That's a huge mistake I did. Beware of this, guys. Shouldn't do mistakes like this in exams, because even though if you have calculated everything correctly, you will make a silly mistake, because that's what I have learned from this, right? So 1 comma x comma y, this will be correct only. This will be 26 31 plus 3 I don't have it. Oh yeah, this shouldn't exist here. That's right. 13 plus 3 is 16. 16 plus 4 is 20. 20 plus 23. That's correct. 23. Now for 2 comma x comma y, we should only calculate for multiples of 2. X values which are multiples of 2. That is 4, 6, 8. 4, 6, 8, right? 4 and 6 are 8. That is 3 plus 2 plus 1. 3 plus 2 plus 1 is 7, right? 7. Similarly for 3 comma x comma y. 3 comma x comma y, again we have to calculate for multiples of 3 for values of x. 6 and 9, that is 3. 4 comma x comma y, only 8. Of course we can't get 5 because x is not 10. That's it, right? Again we'll go for quadruple sets now. 1 comma x comma y comma z, this will be 7 plus 3 plus 1, which is 11. And 2 comma x comma y comma z, which will be only 1, because only 4 can exist, right? Yeah. And for 3 comma x comma y comma z, it's going to be 0. Alright. Now we'll quadruple 5 sets containing 5 elements, y, z, and 5, sorry. Let me resist. This is taking a long time, but I'm sure it's going to be worth. This can only be 1, right? Now I'll zoom out and calculate the total number of sets which are possible. That is that is 18. I'll use calculator for this. It's on my phone, so let me calculate. It is 18 plus 8 plus 5 plus 3 plus 2 plus 2 plus 3 plus 23 plus 7 plus 3 plus 1 plus 11 plus 1 plus 1, which is 88. Let's check the answer. Is it 88? I 105. We have done something very wrong. Why is it 105? For k equals to 19, we calculate for k equals to 18. K equals to 19. Yeah, k equals to 19 only. Yeah, that's correct. Why did I get it wrong? Let me see. As far as I know, this is correct, but why is it wrong? Let me check on 18 plus 8 plus 5 plus 3 plus 2 plus 2 plus 3 is 41. Oh yeah, I forgot 19 also. So it's 19 plus 18 plus 8 plus 5 plus 3 plus 2 plus 2 plus 1 plus 1 plus 1 plus 23 plus 7 plus 3 plus 1 plus 11 plus 1 plus 1, which is 107. Is that correct? Let me check. I'm getting 107. How did I get 105? I must have done something wrong. See, but obviously it's 19. What it is 18 here. That's correct, but let me calculate again. Sorry, 19 plus 18 plus 8 plus 5 plus 3 plus 4 plus 3 plus 23 plus 7 plus 3 plus 5 plus 13 is 107. How will you take it 105? How is that 105? Yeah, but this is the correct way as far as I know. So guys, don't worry, the way is correct, but I don't know why I'm getting what do you call, calculation errors or whatever that is. But this is the correct method, I can assure you that. For today, that's it. Maybe tomorrow I'm going to solve another one. Yep, thank you guys. Oh wow, it's 1 hour 8 minutes. That's long.